Welcome back to Aberdeen Apiary. Today we're switching gears and we're moving from beehive management to beehive creation. Last month I had kind of an explosion in my bee populations and was worried that I was going to run out of space. Now I have a supplier that I go to for beehive boxes and frames and all that stuff, but I take a lot of satisfaction in building my own stuff, and so I try to whenever possible. Sometimes it's not practical, but in this case, I had enough time and I had the resources where I could build it myself. Now, once you factor in the amount of time it took to build these, I don't know if I really saved any money in the long run versus just buying this stuff pre-made over the internet. But this was the choice I made, and it's fairly satisfying to have something you built and you're able to look at it and put to use every single day. And the beehive is no exception. So today I am building 4 brood boxes and 8 honey supers. The construction for each of them is identical. The only difference is the depth. But the process for making them is exactly the same. First, you take the rough board and you cut it to length. You cut the dado, which is what the frames hang on. Then you cut the box joints, which is how the sides are joined together. And then the handholds. Then you assemble the box. And finally, the box is cut to the proper depth using the table saw. Now, a link to the plans that I use can be found in the description below. But without further ado, let's get started. The first thing I did was cut the frames to length. I used my radial arm saw for this. I really like this tool. I really haven't seen any new ones made. I don't know if they still make them anymore. They can be somewhat dangerous, but if you're careful and kind of know what you're doing, they're not too bad. I started out by setting up the stop. This worked okay for the beginning, but you'll see later on I moved the stop, and moving it out from the fence caused fewer problems, which you'll see here shortly. Now, I didn't buy the most expensive wood. It's fairly reliable, but especially for these bigger pieces, they tend to be somewhat warped. Now, because I'm cutting the boards so short, that warp really doesn't matter all that much. That's something that I can correct with clamping. Because this is cheaper wood, you can see there's a fair number of knots in it. As I cut the boards to length, I try to avoid those knot holes, at least having them on the edge. If they're on the edge, they're going to screw up my box joints, but if they're in the middle, they're really not a big deal. This is all very rough, and so it doesn't need to be pretty. It's all getting covered with paint, and so long as the knots aren't on the end, they're fine. Here you see I took just a very thin cut off the end. That's because the boards aren't always square as you get them from the store. A lot of times they're rough cut and on an angle. And so by taking that very thin cut, you're able to make sure that your end is very square. And that's important for making the box joint. Here you see me squaring up the ends of these boards. And because I'm cutting 2 at once, this is the point where I realized that my stop isn't going to work. My stock was only as high as 1 board, and so it wasn't going to work for 2, and so I needed to switch it out. But in doing so, I kind of had a happy accident. By being somewhat lazy, I didn't remove the first stop, which would require me to remeasure the board. Instead, I just put the new stop next to the first one. And the benefit that I came up with was that because it was away from the fence, there was no longer a corner to catch the sawdust. This ended up being really good because, as you noticed, until this point, I was regularly having to clear out that corner of sawdust so that the board would seat properly. What happens is that sawdust builds up in the corner and will slowly migrate the board out so that you're not getting a full length cut. It changes your measurement over time. It makes for really inconsistent pieces. But by moving the stop away from the fence, now there was no longer that corner to trap sawdust. I had just a single line which was away from the blade far enough that it really kind of cleared itself. And so in the future, I'll make sure to put my stop out from the fence. Made the process go a lot quicker and provided much more reliable cuts. The next step was to cut the dado. The dado is the small ledge on each side of the box on which the frames hang off of. Now, there's a couple ways you could do this. I ended up cutting this in 2 passes with a single saw blade. Instead, you could use a dado stack to do this all in one pass. I didn't do it because it required me to set up a sacrificial fence and change out my blades, and I really don't like my dado stack. It doesn't fit very well on the saw. It's safer for me overall just to do 2 passes, and for my money it creates a really clean cut. And here's my feather board. I really like to use this. It helps hold the piece firmly against the fence. At some point I need to build a sacrificial fence. It's a little bit higher, easier to manage. Although in this case it's probably good that it was a little bit low because these boards were warped. It was important that the bottom stay flush against the fence, but the top was free to curve away from it or towards it as it did naturally. So as I said, this is the first pass. Second one will cut off this little notch. You could also do this with a dado stack and a sacrificial fence and just do it in one pass. That'd probably be a little quicker, a little easier, but I don't really like my dado setup, and so I avoid using it if at all possible. And you can see those boards are really warped on here. Okay, pass number 2. You can see I already did kind of a demo cut. I do a test cut every time I reposition the blade just to make sure that the blade is going exactly where I want it to. Now you notice my table saw here doesn't have any kind of guards on it whatsoever, no safety features at all. It's a belt-driven Craftsman built in the 1950s with a solid cast tabletop. It is a great, reliable old saw and also very dangerous if you're not careful. So I try to be as careful as possible. You can see here that without the riving knife and without a blade guard or anything, the offcuts are flinging back towards the operator. I correct this just by standing to the side. I also made sure that my fence was as parallel to the blade as possible. Obviously I didn't get it quite right because the offcuts are still shooting backwards, but they're not doing so with any significant force, and so I wasn't too worried about it. I just stood to the side. But I would recommend for a home shop that you get a modern saw. As cool as these old ones are, they're just not as safe. At some point when I have the disposable income, I will definitely be upgrading my table saw to something a little bit safer. Now it's time to cut the box joints, and to do that we need to do a blade change. Now I don't have a dado stack. Instead I have these little discs, which when you line them up just right, they put the blade on an angle, and it very precisely wobbles back and forth and will cut a dado with a single blade. The first few times I used this, it was scary as hell. There's really nothing as disconcerting as a saw blade spinning at thousands of RPMs and wobbling while it does so. You see here I also had to change out the blade itself. I had a newer blade that I bought that actually had a much smaller kerf than the old one. It went from an 1/8 of an inch to a 1/16, and that was a problem because the kerf of the blade affects the width of the dado that's cut. The sled that I built was designed for this blade, and so I have to hang on to it so I can use it to cut the box joints when I use my sled. Now the other benefit is that using this dado set, it creates a lot of wear and tear on that blade. It's one single blade doing the same amount of cutting as 4 or 5 blades would on a dado stack, and so it's preferable to me to put the wear on the old blade on the new one. You'll notice I have a little spacer that I slide in on the sled before making that first cut. Now on the pieces with the dado cut into it, those ones have to be spaced so that that first cut lines up with that dado. That's important because I need that cut out there so that the adjacent side covers up the dado that I cut. If the cuts were made the other way, where the first row is solid, then when you assemble it, the box, you'll end up with a gap caused by that dado because it's not a full finger that comes out. You can tell these ones I'm cutting now are side pieces because I started that first cut with it all the way up against the jig. Now this is one of the simplest jigs for cutting box joints that you can find. I'll include a link to some plans in the description below, but as you can see, it's a very simple construction, just a simple piece of plywood with a board on the front and back to hold it together, and then a little block that's very carefully positioned exactly one blade width apart, and it is exactly one blade width wide. Alright, now we come to the most complex cut of the build, the handholds. The handholds require that the workpiece be positioned at a 15-degree angle, that the blade be positioned at a 25-degree opposing angle, and that the blade be operated perpendicular to the cut. And so you're actually sliding the blade sideways and cutting laterally across the surface of the blade. You have to be very careful with this because this really isn't how these blades are designed to cut. And so you have to take very shallow cuts so that the teeth cut the material that you want out of there. If you go too deep, then the blade will just bog down, it will bend and warp, and it won't cut, and you run the risk of jamming and breaking the blade. So you see here I have the jig that I built a couple years ago that puts the workpiece on a 15-degree angle. This is where the radial arm saw really comes in handy because it is so versatile. You can position that blade into pretty much any angle you want. You can see here I'm putting it on the 25-degree angle. I have to flip it 180 degrees so that it's opposing the angle of the jig that holds the workpiece. And then it's just a matter of mounting the jig and setting the height. Now the other thing you have to be careful about is that because the blade is spinning, it wants to push the work in the direction that it's spinning. So if you just think about running a piece of wood backwards through a table saw, it's going to catch it, it's going to throw it, and it's going to hurt somebody. And so it's very important to make sure that the jig is properly mounted and that the work is properly braced. You can see here I use a quick clamp that I can open and close, and I install a block on the other end that holds the work in place. And then once all those stops are in place, it's time to get to work. Now I'm making 12 separate boxes, which consist of 48 individual pieces, and every single one of those pieces has a handle on it. You want a handle on each face because you never know when you're out in the field what is the most convenient way to lift that box, which way you're going to be facing the hive, and so you want the versatility to have them all the way around. Now, this is a very complex way to create a handhold when you could just as easily screw a block onto each side. The reason I don't like making handholds out of blocks is because it adds width to the beehive boxes. When you have these built-in handholds, you can stack the boxes directly next to each other. You can see here as I'm cutting, I'm also testing, being very careful not to meet my hand with the saw. Jimmy DiResta stated very elegantly that when you're doing a project like this, the first few times you go to school, and then by the end you're an expert. And so over the course of cutting 48 individual handholds, I learned how many passes I needed to make, how far I needed to drop the saw each time, so that by the end each pass was putting as little strain on the blade as possible and ended up with a very smooth, clean cut. In total, I took 4 passes to create the full handhold. And for the short ends with the dado on it, it's important to put the handhold on the opposite side as that of the dado. But for the long sides, it doesn't matter which side the handle goes on, they can get installed either way. And now it's time for assembly. I built a little jig into my workbench to hold the bottom of the box in place while I fasten the top. Because all these boxes were the exact same size, I could get away with this and simply put the blocks in so that they wedge into place and hold it. The other advantage is that it also keeps the box more or less square. I still had to do some adjustment once it was assembled, but it was pretty minimal. Usually it was out maybe 1/4 of an inch or so, and I could just pull that back in with the clamp with a couple quick turns and just pushing with my hands a little bit. And the nails really did the heavy lifting of holding it in place while the glue dried. The important thing with the glue up is you want to make sure that every surface that meets it every mating surface has glue on it and that it's spread evenly. It's a real pain in the butt with box joints because there's a lot of surfaces you have to get to, which is the point. You know, the box joints, because they have lots of surface, that means they have lots of holding power. You can see I get a little thumbs up. Looks like all my measurements were spot on, Ended up with a really nice looking box joint on these. My last batch of boxes that I made for a worry hive really did not turn out well, so I was excited to see that these did a lot better. I took a lot more time and was careful to make sure that everything was cut right, and it really paid off in the end with a really nice looking box joint. See here, whoops, I glued the wrong surface. It's easy to get mixed up on these. The pieces look so similar end to end, top to bottom, and this wasn't the first time that I messed that up, and it definitely wasn't the last. But it doesn't really matter. I have to glue that other surface anyways. I did notice about halfway through that I did miss a surface here. I needed to put a spot of glue on the top of the other fingers of the box joint. So I don't think it makes much difference with the nails in there. It's pretty solid anyways. And these don't really take a lot of strain side to side. It's really all the vertical, the lifting is where all of the force takes place. These boxes have to hold, up to 35, 40 pounds of honey, plus the equipment. So when it's all told with wax and everything, you're probably looking at 50, 60 pounds. And that's all vertical force as you're holding it by the handholds. And so with the joints themselves, that's more than sufficient to carry that weight. The nails and the glue really just keep it from warping and coming out of square. So you can see that as I'm nailing these, I'm not going all the way to the bottom. I'm leaving that bottom open because I still need to cut these to the proper height. I didn't do that before because by waiting until the box is assembled, you get a really nice, clean, level cut when you cut it all as a single box. That's important because you want the boxes to mate really well with each other. You don't want a lot of air gaps. The bees will fill any air gaps up with propolis, but that also makes them hard to get apart when it's time. So it's best to keep the joints between the boxes as tight as possible, and by cutting it all together in the table saw, you end up with a really nice level surface that allows the boxes to stack really well. The tedious part of woodworking is the part I really enjoy. It's almost like meditation. When you get into a rhythm, you're doing the same thing over and over again, it really seems kind of dull, and it is. But I put some music on and put the assembly together and just think about life and what I'm doing and where I'm going, and thinking about the other things I need to do for this project or other problems that might come up, or problem solving. It's just a really zen moment for me when I'm in this moment doing this tedious, repetitive task. Not that I was happy to have it all done, but I try to appreciate the moment as well. Once the boxes were all assembled, I could finally test with a frame, and it was the moment of truth to see whether all the measurements that I'd made and the plans that I'd used actually worked with the frames that I had. So I brought out a completed frame, stuck it in, and you want it to have just a little bit of wiggle room front to back. That allows them to fill in, and you can see that it was just spot on perfect. Final step is to cut the box to the proper width. Got to be very careful here. I almost put this on the wrong way. That you want to cut the bottom off, not the top. If you cut the top, you screw up your dados. So cut the bottom off. You get that nice level bottom that I was talking about. It lets the boxes mate really well with each other vertically. And I ended up with a whole bunch of really thin picture frames that are more or less useless. And after this, it was paint, and then they're ready to install. So that was my weekend building beehive boxes. Ended up taking a lot of time. As I said before, I don't know if it was really worth it. I could have just bought this stuff online. But at the end of the day, I did save a few bucks. All it took me was time, and I ended up with a really rewarding experience and having something I built being put to use every single day, and I get to look at it when I do my inspections, and it's something that I really feel proud of. So that's the end of our video for today. I hope you enjoyed it. If you like this video, if you want to see more, please like and subscribe. Thanks for watching.